All right, guys, here's your practice test. Let's do this thing. Hope you're enjoying your day off. First one, graphing these two equations for 1 and 2. First one, we talked about cover. Forget the 6y for a second. Just look at the x. 3 goes into 12 4 times, so putting a point on the 4 on the x-axis. Now look at just the y. Negative 6 goes into 12 negative 2 times on the y-axis. Connect the dots, la, la, la. And that's all you got to do. Number two is a little bit different. It's slope-intercept form. You graph your y-intercept first, which is at 3. Your slope is 1/4, which means you remember slope is rise over run. So I'm going to rise 1, run 4. There's my 2 points again. Connect the dots, la, la, la. And there's number 2. Let's go to 3. 3 says find the distance and the midpoint. Remember the distance formula? Give it to you yesterday. You're going to subtract your x's. So I'm going to go 2 minus negative 12, and then you square it. I'm going to subtract the y's. Negative 4 minus negative. Make sure you know that formula tomorrow. Squared. When you work those out, you get, let's see here, you get 196. When you square that one, here you're going to get 121. When you add those up, I believe it is 317 inside the square root. Right, and if you can break it down, please break it down. That one does not simplify, so you're just kind of stuck there. The midpoint, remember you add your x's. So I'm going to add the negative 12 and 2. That's negative 10 divided by 2, negative 5. So you add your x's, divide by 2. Then I'm going to add the y's and divide by 2. If I add those two y's, I get negative 19 divided by 2 is just negative 19 over 2. So long story short, if you get an even number when you add your x's or y's, you just cut it in half. If you get an odd number when you divide by 2, you just put it over 2. Number 4, find an equation of the circle with the center, negative 2, 4, and passes through 3, 5. The center always goes inside your parentheses. Remember, it's the opposite of what's inside. So you're going x plus 2 squared plus y minus 4 squared. Do not forget that plus sign right there. Equals. To figure out what our equation is going to equal, remember it equals r squared. To find our radius, instead of doing all this work to find the radius, we're going to use something that we know. And that is if a line passes or a circle passes through a point, the reason it passes through that point is because it works in the equation. It solves the equation. So I'm going to put a little 3 here for the x, a little 5 there for the y. See what happens. 3 plus 2 is 5. Squared is 25. 5 minus 4 is 1 squared, which is 1. 25 plus 1 is 26. There's your equation. That's what it should look like. X plus 2 squared plus y minus 4 squared equals r squared, which is 26. Number 5. Determine if it's a relation as a function. Identify the domain and range. First of all, remember the domain are your x's, your x coordinates, which are 5, 7, and 9. Your range is your y coordinates, which are 2, 3, 4, and 5. Then it's going to ask you, is it a function or not? And this is a no, because remember, a function is every x has exactly one y. And if we look at this one, that's a 5. But the 5 has a 2 for a y and a 3 for a y. So every x doesn't have the one y. The 5 has 2 different y's. So it's a no. Number 6, it's going to have 3 answers here for number 6. You got to do f of negative 1 first, which means I'm just going to take the negative 1 and plug it in, which is going to be 3 times negative 1 squared plus 5 times. I said this to you guys yesterday. Make sure that if you use your calculator for this, which I'm assuming you will do, please use parentheses like I just wrote that down. If you don't, your calculator will, it's weird to say this, but it'll mess you up. So make sure you do that. That's going to be negative 2, it looks like. F of 4, plugging in 4 here. So I'm going to do 3 times, I don't know what's going on here with this iPad. This is like 6th week of school and I'm still doing this stuff. Okay, so 3 times 4 squared plus 5 times 4. 4 squared is 16. 16 times 3 is 48 plus 20. That'd be 68. And then the last part of 6 is the toughest part probably. I'm going to erase those two real quick so I can fit this on here. Is the f of a plus 1. F of a plus 1. So I'm going to plug in the a plus 1 where all the x's are. So it's going to look like 3 times a plus 1 squared plus 5 times a plus 1. Your job is to work all that out. So first thing I'm going to square this, which is square, multiply, double square. Do not distribute the 3 until you square. Exponents always go before multiplication. Please excuse my dear Aunt Sally. Now distribute the 3. 3a squared plus 6a plus 3 plus 5a plus 5 And then I'm just going to add the stuff that they have in common. 3a squared is good. They have a 6a and a 5a. That's 11a. Have a 3 and a 5. That's 8. And there you go. That's the last part of 6. Very careful there. Be so careful. Number 7. Exact same kind of problem. Plug in the 5. You get 5 minus 3 over 5 plus 1. That gives you 2 6, which reduces down to 1/3. No big deal there. Do the same thing with the negative 1, except something weird happens when you plug in negative 1. What happens when you plug in negative 1? You get a 0 in your denominator, which hopefully you know by now in your life. That is illegal. You can't divide anything by 0. That means it is undefined. No definition for that. Undefined. Number 8, find the domain. Remember how we start these? Remember, domain means what the x's are, or what are you allowed to put in for x, and what you're not allowed to put in for x. And we always do this. We put a little squiggly bar. We say x with the bar, which means all x such that. And then we tell it, we say x can be everything except for. What can x not be? Well, in this case, x cannot be 1, because if you plugged 1 in that function up here, it'd make your denominator equal 0, which is illegal. All right, number 9, negative exponent. Now, up to you how you do this. There's really 2 ways to go through and do this problem. I'm going to show you the way I would do it. I would go ahead. Usually I would say work inside if you can, and if you want to do that, that's fine. But this time, because there's negative exponents everywhere, inside and outside, I realize when I multiply those exponents, they're all going to become positive anyway, so I'm going to go ahead and do the exponent. The exponent on the outside goes for everything in there. So it goes for the negative 3. It goes for the x, which you multiply negative 4 times negative 2. It goes for the z, which you multiply negative 2 times negative 2. And you're done there except for this term right here. Okay, you got negative 3 to the negative 2 power. Now, the negative 2 power means 2 things. You have to square it, and you got to flip it. Just the 3. So the x to the 8th, the z to the 4th is going to stay on top. And I'm going to square the negative 3, which makes it 9. And the negative is going to flip it to the bottom. And there it is. I hope that makes sense to you. That's the hardest part of the problem. The negative 2 exponent means you square and flip. You got to do both things. Number 10, slide, divide, slide. Sliding the 2 to the end there, x squared plus 9x, that's going to be 112. Come on now. Factor that. Everybody knows the factors of 112 are like, 16 and 7. I'm being sarcastic there. Not everybody knows that, but you can find those by just choosing, because the middle number is 9, just pick numbers that differ by 9 and keep trying them until you find one that gives you 112. That's the slide part. Now I got to divide by 2. If I divide 16 by 2, I get 8. I can't divide 7 by 2, which means I'm going to slide the 2 back in front. And there it is. There's the factorization. Slide, divide, slide. Number 11. You're allowed to multiply radicals as long as the index is the same. These are both square roots. So I'm going to multiply them together. I get 24x to the 8th y squared. Now I'm just going to break that down as much as I can. 24 is really 4 times 6. So the square root of 4 is 2. I'm going to take the 2 out. I don't know what the square root of 6 is, so it's going to stay in. And there's really a 2 right there because it's a square root. I'm going to divide that 2 into the exponents. 2 goes into 8 4 times, so pull out x to the 4th. 2 goes into 2 1 time, so pull out 1y. And guys, that's it. That's all you can do. Number 12, getting close. 12, I'm going to factor all this stuff and then try to cancel what I'm multiplying. If it was division, I would keep change flip, but it's multiplication, so I'm just going to factor and cancel. So I have x plus 4. Down here, I can take out a 2x. Remember, you always look for GCF first, always. So on the top over here, I'm take out an x squared. If I take out an x squared, that leaves another x squared minus 9. And down here, I have an x plus 4, x minus 2. That just flat out factored everything, except this x squared minus 9 on the top, that numerator, that's the difference of squares. That actually factors some more. It'd be x plus 3, x minus 3. So I'm just going to erase that real quick and put that here. X plus 3 instead of writing all that stuff all over again. X plus 3, x minus 3. And I'm just going to cancel what I can. I see an x plus 4. They're out of here. The x minus 3s are out of here. And this is a weird one. There's 1x down here and 2x's up here, which leaves 1x on the top when I cancel those. So what's left in my numerator? An x and an x plus 3. What's left in my denominator? A 2. Don't forget that 2 right there. And an x minus 2. And that's it. 13. Square, multiply, double square. So I'm going to square the first term. If you square a square root, the square root goes away. I'm going to multiply these together. And if I multiply those together, guys, you get a negative 7 on 3. But then you got to double. And when you double, remember, you don't double what's inside. You double the number outside. Usually we put a 2 there. But because there's a 7, I'm just going to double the 7, make it 14. Then I'm going to square the 7, make it 49. And now, don't leave it like that. Some of you did that last week. You can have a 3 and a 49. You can combine those. You need to do that. That's hence the direction, simplify. And there it is, 52 minus 14 on 3. And the last problem, finally, absolute value 4 minus pi. Here's what you know about absolute value. The absolute value of any positive number is itself. The absolute value of a negative number is the opposite of itself. So this one, 4 minus pi. Remember, pi, an estimate for pi is not 3.14, but that is an estimate we use a lot. All right, that's a positive number. So what is the absolute value of any positive number? Itself, so it's 4 minus pi. Now, if it would have been negative, if it had been a negative absolute value, I would have changed this out on a 4, I would have changed this out on a pi, and that would have been the answer. Okay, but it was positive, so there it is. Hope that helps you a little bit. Watch as much as you need to. Please watch some, make me feel good about doing this. Again, hope you're enjoying your day off. See you on test day tomorrow.